Okay, so this week we're going to be doing the 2022 AMC 10B. I'll probably just do problems 15 through 17 in this video, just because, if you've seen the later problems like 18 through 25, or just 18 through 20, they're way harder than they normally are on the AMC 10, so it would take way too long. But of course, if you have any specific problem requests, feel free to leave it in the comments and I'll try to reply as quickly as possible. Okay, so let's get started. This is number 15 on this year's AMC 10B. Let S sub n be the sum of the first n terms of an arithmetic sequence that has a common difference of 2. The quotient S sub 3n divided by S sub n does not depend on n. What is S sub 20? Okay, so first let's write this arithmetic sequence in terms of a variable. So let's say the first term is a. I'll just write the number of the term here. It has common difference of 2, so each term will be like a plus 2, a plus 4, a plus 6, a plus 8, a plus 10, etc. And actually 1, 2, 3, 4, 5, 6. Okay, and it says that the quotient S sub 3 divided by S sub n does not depend on n. So let's just take two cases, where one is where n is equal to 1, and we're going to want to find S sub 3 divided by S sub 1. And the other case will be n equals 2, which will be S sub 6 divided by S sub 2. S sub 3 will be the sum of the first three terms. That's going to be 3a plus 6. S sub 1 is just a. And S sub 6 will be the sum of all of the terms. So that'll be 6a plus 2, 6, 12, 20, 30, divided by S sub 2, which is 2a plus 2. And we can simplify this into 3a plus 10 over a plus 1. Oh, sorry, this would be 2a plus 10. Okay, no, sorry. 3a plus 15. Okay. And we're given that these don't depend on n, which means these two fractions must be equal. So let's just solve for a in that case. Over a plus 1. Here we have 3a squared plus 3a plus 9a plus 6. 3a squared plus 15a. 6a, so a is equal to 1. Okay, so that means our sequence is just 1, 3, 5, 7, 9. Yeah, so it's just all the odd numbers. And we want to find S sub 20. Now, the sum of the first n odd integers will just be n squared. So this means that S sub 20 is just 20 squared, so that'll be 400, which is D. Okay, and this is number 16. The diagram below shows a rectangle with side lengths 4 and 8, and a square with side length 5. The vertices of the square lie on 3 different sides of the rectangle, as shown. What is the area of the region inside both the square and the rectangle? So we want to find the area of this. So first, notice that this area, or region, is just a trapezoid, because the sides of a square are parallel, so this will be parallel to this. Okay, and we also know that, so this is 4, this is also 4, and this will be 5, which means if we just draw this part here, this will be 3, and this will be 4 as well. So we have a 3, 4, 5 right triangle there. Okay, so we have one of the bases of a trapezoid, which is 5, and we also have the height, which is also 5. So all we want to do is find the length of this small triangle. So let's see how we can do that. Okay. So notice that these two triangles, I'll just label them with letters just to make it easier. So triangle ABC is similar to triangle CDE, because if this is x, this will be 90 minus x. So we can use similar triangle ratios to find the side lengths of this triangle here. So let's just write, let's say CE divided by 5 is equal to 4 divided by 5 as well. So actually, yes. Actually, no, we don't have this. We didn't have to say that it was similar. They're just congruent by SAS because they're both right triangles and they share a side length, which is 5. So by, sorry, not SAS, ASA. So these are congruent triangles, which means this is 3. Sorry, no, this is 4 actually, and this is 3. Okay, and this means that this must be 1. And as I said earlier, this triangle is also similar. So if this is x, this will be 90 minus x. And so I'll just write it bigger here. This angle here is 90 minus x. So we can just use similar triangles. We have that 1 divided by 4 is equal to this length, hypotenuse. I'll just say this is f. df divided by 5. So 5 is equal to 4 df, and df is 5/4. Okay, so now we have all the necessary parts of the trapezoid to find the area. So the area is going to be 5 plus 5/4 divided by 2 times the height, which is 5. So this would be 25/8 times 5. 125/8, which is 15 and 5/8. So that's going to be D. Okay, and on to the last problem. This will be problem 17. One of the following numbers is not divisible by any prime number less than 10. Which is it? So to solve this problem, we're going to have to just test prime numbers that are less than 10, namely 2, 3, 5, and 7. And hopefully we'll find that some of the choices are divisible by those numbers, and then the remaining choice will be the answer. So clearly none of them are divisible by 2, because you have -1 here, +1 here, -1, +1, and then for the last one, 3 to the 6 of 7 is odd, so the even plus an odd is going to be odd. So none of them, so 2 is not going to help us eliminate any choices. Next, let's look at mod 3. Powers of 2, mod 3. 2 to the first will be 2 mod 3. 2 squared will be 4, which is 1. 2 cubed will be 2, and then the pattern continues like that. So 2, 1, 2, 1, 2, 1, etc. So for odd powers, it'll be 2, and for even powers, it'll be 1. So that helps us with choices A, B, C, and D. So we know that 2 to the 606 will be the same as 1 mod 3. So minus 1 will be 0 mod 3. So this is divisible by 3. This will now be divisible by 3. 2 to the 607 will be 2 mod 3. So if we add 1, that's going to be 3 mod 3. So this is also divisible by 3. And then this is clearly not divisible by 3 because 3 divides 3 to the 607, but it doesn't divide 2 to the 607. So yeah. Now let's look at mod 5. So powers of 2 mod 5, it'll go like 2, 4, 8 is 3, and then 6 is 1. And then it'll be 2, 4, 3, 1 again. So it repeats in patterns, or sorry, groups of 4. So all we have to do is divide each power by 4 to figure out what it is mod 5. So 606 divided by 4 is 2. So that'll be 4 mod 5. And then plus 1 will be 5 mod 5, so this is divisible by 5. For C, it'll be to the 607, which is going to be 3. Minus 1, that's going to be 2 mod 5, so that's not going to be divisible by 5. And then for this one, 2 to the 607 is 3 mod 5. 3 to the 607, we have to test that separately. So mod 5 for powers of 3, it'll be 3. 9 is 4 mod 5. 12 is 2 mod 5. 6 is 1 mod 5. So it's going to repeat in patterns, or sorry, groups of 4. So 3 to the 607 mod 4 is 3. That's going to give us 2 mod 5. So 3 plus 2 equals 5, which means this is divisible by 5, and our only possible choice is going to be choice C. So that's going to be it for this week's problems. I hope you enjoyed the video, and of course, be sure to like and subscribe, and leave any comments of what problems you would like to see next.